Once again, welcome to Future Knowledge Bank. Dear viewers, I came to know that lot of the people and the students of the intermediate and 12th class struggling to learn the concepts of electricity. Don't struggle, get relaxed. Here we can learn the concepts of electricity in a playful manner, and don't take it as a serious. Completely a playful manner you go for it. And so in this video, what topics I'm dealing, you can see with very relaxedly. The first one, electric current. Second topic, drift velocity. Third one, current density. Fourth one, mobility. And fifth one, Ohm's law. And sixth one, resistance and factors. And seventh one, specific resistance. And the eighth one, conductance. And the ninth one, conductivity. Now, the concept of the number one, electric current. Electric current in the sense is, it is a rate of flow of electrons in a conductor. That means, what speed the electrons are moving in one electric conductor, and that is nothing but electric conductor. So that is what means 3 into 10 to the power of 8 electrons move in 1 second. That is the speed of the electricity. So simply we can say that what speed the electrons are moving is nothing but electric current, and it is indicated by the letter I. And now comes to the point of the formulae, how to calculate the electric current. To calculate the current, we will take very simple, current equal to charge by time. Here current is denoted by the letter I equal to NE by T. Here N represents number of electrons, E represents charge of the electron, that is nothing but 1.6 into 10 to the power of minus 19 coulombs, and T represents the time. Now, two cases we can see here. The first thing is, if electric flow is in a steady manner, this is the formula to calculate the steady current here. I is equals to NE by T. If the electric current is non-steady, that occasion I is equals to delta Q by delta T. So these are the two types of movements we can see in electric current. Thereafter, what is the meaning of conventional current? You can see the movement of electrons from the higher potential to lower potential, we can call it is conventional current. That is nothing but the positive charge is moving from the negative charge. That is called electric current. So it is a very simple way to go for electric current. The second one is drift velocity. The meaning of the drift velocity is the average velocity attained by the electrons of a given material due to an electric field is called drift velocity. This is directly proportional to the current. Comes to the point how to calculate the drift velocity. We have in one formula here. Drift velocity Vd is equals to I by NEA. Here I means the current flow in the material, N means the number of electrons, E means the charge of electron, and A means the area of cross section of the conductor. So we can calculate with this formula the drift velocity of the material. The topic number 3, current density. The meaning of the current density is the amount of electric current traveling per unit area of cross section is called current density. That means how much amount of electrons are moving from in that particular area of cross section, that we call as current density. It may be some occasions the amount will be low, some occasions the amount will be more. That is, we can say current density, low voltage and high voltage. in regularly we'll say in our houses. Now to calculate this one, we are having a formula, simple formula, J is equals to I by A. The topic number 4, mobility. Mobility in the sense the drift velocity acquired per unit electric field is called mobility. That means how much drift velocity gathering in 1 unit electric field. Mobility is going to be calculated by this formula. Mu is equals to Qt by M. Here the letter Q refers for charge of the conductor, T refers for relaxation time, M represents for mass of the charge carrier. So we can calculate any kind of mobility of the electric field in that way. And it is having one specific dimension formula here, mass inverse, length naught, and T square and 8. So this is the important dimension formula for the mobility. Now topic number 5, very important topic here, Ohm's law. That Ohm's law says that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and the temperature remains constant. The meaning of it, the voltage, whatever the voltage present in the power source is directly proportional to the current flow. That means more voltage in the battery, more current flow will be there. Less voltage in the battery, less current will be there. According to the Ohm's law, voltage directly proportional to current flow. We want to calculate what kind of voltage, how can we change the flow of current. And it is impossible to calculate without removing the constant here. So we have to apply the constant here, we have to remove the proportionality here. So now V is equals to IR. Here V is the voltage, I is the current, and R is the resistance. And here where R is the constant of the conductor and it is called resistance. So resistance is the one kind of value which helps to calculate the voltage and the current here. Now the topic number 6, resistance and its factors. Now the meaning of the resistance is a measure of opposition to the current flow in electric circuit. That means it is the opposition force to stop the flow of electrical charges. Suppose one car is moving, certainly a kind of obstruction has come in front of the car. The driver will apply the brakes and the car going to stops. And the way the car is stopping is nothing but resistance here, opposition force to the movement of the car. So resistance also is an opposition force to stop the flow of electrons. So now this one, how this resistance is affecting the different factors. What are the factors which resistance is getting affected means we are having the factors. Now we'll discuss the factors. Now the resistance is going to be influenced by the two or more factors. The factor number 1, length. If the length of the resistor wire is increasing, the resistance also increases. If the length of the resistance wire is decreasing, the resistance also decreases. This is we can consider as directly proportional. The factor number 2, area of cross section. The area of cross section is inversely proportional to the resistance. Suppose the area of cross section is more, the resistance will be less. If the area of cross section is less, the resistance will be more. This is the inversely proportional. And taking these two factors, we are combining and getting one common relationship between these two. Now resistance is directly proportional to length of the wire and inversely proportional to area of cross section. And as we know, we have to remove the proportionality to calculate the resistance here. So, by removing the proportionality, we are applying the one constant value rho. Rho is nothing but a constant material of the conductor is nothing but resistivity. The resistance can be calculated by using this formula R equal to rho L by A. Rho is a constant property of the material, L is the length of the resistance wire, A is the area of cross section. And also this rho is called resistivity or specific resistance of a material. This resistivity depends upon the material. It can be calculated by using this formula M by N E square T. Here the resistivity unit is ohm meter. So now the dimensional formula for the resistivity is M L cube and T to the power of -3 and A -2. Now the next two topics are conductance and conductivity. Here the definition of conductance is the inverse of resistance, which means that is a measure of how easily the current will flow through the material. That means what is the method, what kind of the sense that current will flow easily through the material. That is called conductance. And next is conductivity. It is a property of the material which tells how easily current will be able to flow through the material and how much easy and how easy. So these are the two different types of material we can measure by the following formula. Now, how to calculate the conductance? Here, the conductance denoted by the letter G is nothing but 1 by R. That means inverse of resistance. The unit of the conductance is ohm inverse, or we can say mho, or we can call MOH, that is Simon. Simon is a unit for the conductance. And the dimensional formula for conductance is M inverse L cube and T cube and A square. Now, how to calculate the conductivity means by using the reciprocal of the resistivity, we can calculate the conductivity. It is denoted by the letter sigma. Sigma is equals to 1 by rho or equal to N E square T by M. Here N means number of electrons and charge of the electron and relaxation time and mass of the charge carrier. Now another way, what are the different formulae to calculate the resistance according to the data given in the problems? Here you see, first one, if the resistance material is cylindrical form, we are going to use this formula. R is equals to rho L by pi r square if the resistance wire is cylindrical form. Now comes the point, the resistance also can be calculated by using this formula when it is given mass, volume and density. Now R is equals to rho L square by D by M. I hope so you understood this video perfectly. And next part number 3 of electricity and part number 4 of electricity completely having the few concepts and most of the problems. In the next videos you can see more technical developments in our future knowledge bank. Dear viewers, ఈ వీడియో కనుక మీకు నచ్చినట్లయితే మీరు లైక్ చేయండి, షేర్ చేయండి. మరిన్ని మంచి వీడియోలు, మీకు మంచి జ్ఞానాన్ని, నాలెడ్జ్ని ఇచ్చే వీడియోలు మీ ముందు పెడతా. More knowledgeable videos will come because our channel is Future Knowledge Bank. Knowledge is our motto. Subscribe and like and share.